So, good afternoon, everyone. I, Prajwal Chawda, along with Rizwan Ali and Dr. Vikram Puri from IIIT Hyderabad, India, are here to present our work, CRICTRS, Embedding-based Statistical and Semi-supervised Cricket Team Recommendation System. So before we start, I would like to share a small video just to give an overview of the game of cricket. Can you hear the audio of the video?
No.
No. Oh, wait. I'll. Does it work now?
Yep.
Cricket is a sport that is played by millions and loved by billions of people from all corners of the globe. Cricket has been played for centuries, with the first international match occurring way back in 1844. From that time, it has continued to develop into the vibrant and exciting modern game that is played today. Cricket is a bat and ball sport that involves two teams with 11 players on each side. The aim of the game is to score more runs than the opposition. One player, the bowler, bowls a hard leather ball that speeds of up to 150 kilometers per hour at a player from the opposing team, who then attempts to hit it with a bat in order to score runs. Cricket is played on an oval-shaped field, and in the middle of that field is the pitch, which is where most of the action takes place. At either end of the pitch, you'll find these things. They're called wickets, and they're made up of 3 wooden stumps that support 2 bails. They're important, but we'll come back to them shortly. The batting team has 2 batters at a time in play, whilst the fielding side has all 11 players on the field. A batter scores runs in 2 ways. 1. They hit the ball far enough that it crosses the outer boundary of the field. If the ball has bounced, it's worth 4 runs. If it clears the boundary on the full, it's worth 6, the maximum number of runs that can be scored from 1 hit. 2. Through the 2 batters running the length of the pitch in opposite directions whilst the fielders are retrieving the ball. 1 length of the pitch completed equals 1 run. The aim for the fielding side is to restrict the number of runs scored by the batting side, whilst trying to get the batter out. There are 11 different ways a batter can be out, with the most common being bowled. The bowler bowls the ball, the batter misses it or deflects it by accident, it hits the stumps and the bails come off. Caught. The batter hits the ball and one of the fielders catches it before it hits the ground. Leg before wicket, LBW. Exactly what the name suggests. The bowler bowls the ball, the batter misses it, and the ball hits them on the leg in line with the stumps. Run out. The batter hits the ball and runs, but the fielding team retrieve the ball and throw it to the stumps before either batter has reached the other end. When a batter's out, they leave the field of play and another teammate replaces them. Once all the batters on a team are out, the sides swap, and the fielding team then have their turn to bat and attempt to beat the overall score set by the first batting team. Put simply, the winner is the team with the most runs after both sides have batted.
Also, I would like to add more to this. Cricket is a sport that is discrete in nature. It is essentially played in three formats. The oldest form being the Test cricket, where two teams compete in a 5 day long match. And much like the two-leg format in soccer and other sports, each team gets the chance to bat twice alternatively. A peculiar thing about this format is that you may end up with no result even after 5 days of the match, and the match is declared drawn. Next, we have ODI cricket or the One Day International, a 50 over per side match where each over has 6 balls. The third one being the T20 or 2020 format. In this, each side has a 20 over quota with each over being 6 balls. So for a study, we considered the ODI format of the game in which each side bats for 50 overs, that is 300 balls. Now I would like to present the abstract of our work. Team recommendation has always been a challenging aspect in team sports. Such recommendation systems aim to recommend a group of players best suited against the opposition team. In this paper, we propose a semi-supervised statistical approach to build a team recommendation system for the cricket by modeling players into embeddings. To build these embeddings, we design a qualitative and quantitative rating system which considers the strength of opposition also for evaluating players' performance. A critical aspect of team composition, which includes the number of batsmen, bowlers, and all-rounders in the team, was also considered. The team composition usually changes over time depending on different factors like weather, pitch conditions, group dimensions, etc., which are tough to predict in statistical settings. So we take this input from the user or coach and use the player embeddings to decide the best possible team combination with given team composition. For our work, we use CRICTRS.org dataset, which is an open source dataset having ball by ball match proceedings of over 1500 matches from year 2003. These are the two main components of our system, the player rating mechanism and the semi-supervised team recommendation system. In our work, we build a player rating algorithm called quality index of player performance, represented by 5 players. And to start with, I would like to discuss how we modeled a cricket match. So, a cricket match is essentially a collection of complex events, and for ease of statistical analysis, we abstracted out these complexities and built on the idea proposed by one mentioned here, and by modeling our match as a collection of Bernoulli events, where each delivery is a Bernoulli trial. So for a particular delivery, we have two possible outcomes. Either we can have R runs scored or a wicket fallen. So here R is the average run scored per delivery, and there can be at most 10 wickets per innings as per the rules of cricket. So cricket inning in an ODI match can go up to 300 balls or until the point where 10 wickets have fallen. So using the above scenarios, we can calculate the expected runs scored by a player as follows. First, we create a team having 11 replicas of a player, which is to be considered for evaluation. And then we can get expected runs scored for the player using the following self-explanatory equations. So the expected runs for a player is a summation of two scenarios mentioned here. So when we have an all out, that is all 10 wickets of the batting side have fallen within 50 overs. And second scenario, when we don't have an all out and when the batting side completes their quota of 50 overs without losing all 10 wickets. So the player rating mechanism of 5 player is different from others as we modified and reevaluated the run scored and wicket taken by multiplying our quality metrics, which were evaluated as shown here. So this is how we evaluate our quality index of player performance. Some notable improvements that we observed in five-player over the existing work in literature are following. So, in cricket, there are bowlers who bowl at different average speed, and these are categorized as different bowlers. So, bowler type. So there are three main notable bowler types. The fast bowler who bowls at a speed of over 130 km per hour, and then we have spinners who bowl slower than 100 km per hour, and finally we have medium pacers who bowl in the range of 100 to 130 km per hour. So most of the existing player rating mechanisms uh, give a certain preference to spin bowlers. As you can see here, we have taken uh, work from literature, and it gives so in the bottom table number two, Harbhajan Singh, the fourth row, is a spin bowler. So as you can see, there is a certain inconsistency, and a significantly higher number is given to this bowler. So these anomalies exist in the work. So we improved upon, so by using quality metrics, we improved over this. And as you can see in the second column of the table two, Harbhajan Singh has a rating within the range of other fast bowlers. So this is one major improvement of the quality index of player performance. Next, we also considered the extra run. So there are certain rules. So when a bowler bowls some illegal deliveries, then extra runs are awarded to the batting side. So we also considered that, and this is usually ignored by many work until now. So also the ranking among the player changes when we consider quality metrics. So an example is shown here. So on the left we see Virat Kohli, current captain of Indian team, and we analyze his rating comparison over the years. Statistically, Virat scored lesser runs in 2012 as compared to 2016. The metrics which only considered the quantitative aspects of the performance, as mentioned here in blue. So it has given a significantly higher rating in 2016. But if we look closely, Virat faced higher ranked opposition in 2012. And although he scored around 100 runs less in year 2012, his performance should be ranked higher as compared to 2016, where he faced low ranked teams. So also we analyzed it for a bowler. Here we have Pat Cummins, an Australian bowler. So here also we see similar trends where there is a difference in the rating by quality metrics and quantitative metrics. So the next part of our recommendation system is the semi-supervised team recommendation, where we use player embeddings. So using five player, we model players as embeddings as described here. So consider a player A, let's say a batsman, and player B, let's say a bowler. So first we assign a unique number to every batsman shown here, and we repeat the same for the bowlers as well. And each player is modeled as a vector. So we have two level of embeddings as defined here. So for a batsman, level one embedding is a vector where index I of the embedding gives the quality index of batsman performance against the bowler assigned the number I. And similarly for a bowler, where the level one embedding is also a vector where index I of the embedding gives the quality index of bowler's performance against the batsman with index I. And to derive the level 2 embeddings, we do the following. And for every batsman, we compare the five player over his career against all the bowlers with the values at every index of the level 1 embeddings. So if the player has have faced each other and there is a significant negative deviation in the performance of the batsman, that is, there is a drop in his performance, uh, then the index is set to 0, and otherwise it is set to 1. So these are the example embeddings. So here we have taken four batsmen and four bowlers and listed out them as follows. So these are the level one embeddings. Using the level one embeddings and checking the deviation in the performance, we can derive a level two embeddings as follows. And these are the example level 1 and level 2 embeddings. So for batsman 1, we can see here that when he faced bowler 1 and bowler 3, he had a certain rating. And when he faced bowler 4, suddenly his rating dropped significantly. So we can conclude that the batsman 1 is does not play as better as he plays in the usual setting. So we assign a number 0 to the batsman at index 4. So the next part of the system is the team selection. As now we have the embeddings, we design our algorithm to derive a least risk giving team from this. So first, before starting, let us understand team composition. So team composition means the number of wicket keepers, batsmen, bowlers, and all-rounders in a team of 11 players. So here is an example. We have taken taken team for the Bangladesh versus South Africa Cricket World Cup 2019 match, and as you can see, a role is assigned to each player next in the brackets. So Tamim Iqbal is a batsman and Shakib Al Hasan is a all-rounder. So the team composition usually changes over time depending on different factors. So these are often tough to predict in a simple statistical settings, and there can be a lot of variation. So we take this input from the user and use the player embeddings to decide the best possible team combination with the inputted team composition. So as per the rules of cricket, we had the following constraints on a solution. So we need to return at least 11 players in the collection, among which we can provide them rankings. And as per the requirement, the coach or the team can decide who all will play for them. And also we considered the ODI format of the game. And as per the rules, we must have five bowlers and all-rounders. So all-rounders are basically the players who can bat as well as bowl. So also there is a constraint rule in the cricket that a player in an ODI match cannot bowl more than 10 overs. So a team must have at least five bowlers and all-rounders to for the same. And last, there one must be at least one wicket keeper so to stand behind the stumps. So the proposed solution that we gave satisfied the following constraint. So what we did was we uh, first of all we selected the wicket keeper, and then the leftover wicket keeper provided in the input were assigned the role of the batsman, and then as per the constraint the selection was made based on uh, the player embeddings and quality index of player performance. So this problem can be represented in terms of a bipartite graph using level 2 embeddings, where we list out all the players for which our opposition team players are weak, and we define a similarity metric, and we see that, let's say, a player A in our opposition team is weak against a player B in some other team. So we see which player in our team is most similar to that player, and when we find that player, we can draw an edge from the player A in the opposition team to our player. So this way we can get a bipartite graph as follows. So the players on the right hand side are the opposition team players. So on the left half of the bipartite, on the left bipartite graph, we have our batsmen listed out against opposition bowlers. As I mentioned, first of all we see like which all players against which all players the opposition players performance drops, and after checking similarity from those players to our team players, we get the following bipartite graph representation. So once we have all this, so we define the following metric delta, that is mean of edge weights and divided by the standard deviation of the edge weights. So the main purpose for this was that we must not include the high variance player as it reduces the stability of a final team combination. So the idea is same from the quality index metric, that we must have a consistent performance by the player, and there must not be a lot of variation. So if we include player with variation, that provides a lot of risk and uncertainties in the final result. So that's it. So for the result part, we considered comparing the teams recommended by our system and the teams that played in the actual matches. So we considered only the World ICC World Cup 2019 matches, and we observed that the whatever team was recommended by our system had higher similarity with the team that played in the actual match and won, and the team recommended by our system had a low similarity with the team that played in the actual matches and lost. So this can be considered an important indicator that CRICTRS indeed provides good recommendation. And also the future aspects of this system are follows, that recently the ICC announced, ICC, that is the International Cricket Council, it announced a rule, concussion replacement rule, where if a player suffers from a concussion during the match, then the player can be replaced by another player. But there is a lot of controversy around it, and the like for like replacement mentioned by ICC is under scrutiny. So CRICTRS embeddings can be used to analyze the player embeddings of the player who suffered concussion and the player who is to be replaced. So if there's a similarity, then we can say that there is a like for like replacement, and if similarity is low, then we can argue that the player is not suitable for this replacement. So these are the references.